Welcome to Science in 10 Minutes. Today we're diving into the fascinating world of chemistry to explore the periodic table of elements. Imagine a chart that organizes all the known ingredients that make up everything around us, from the air we breathe to the stars in the night sky. That's the periodic table. This incredible tool, developed over centuries by brilliant minds, is like a chemist's best friend. It's a roadmap that helps us understand the properties of elements, how they behave, and how they interact with each other to form the compounds that make up our world. So buckle up as we embark on a journey to unravel the mysteries of the periodic table and discover the amazing world of elements. Get ready to be amazed by the building blocks of the universe.
The periodic table is like a giant puzzle, where each piece represents a unique element. Elements are the simplest pure substances, and they can't be broken down into anything simpler by ordinary chemical means. Think of elements like the letters of the alphabet. Just as letters combine to form words, elements combine to form everything around us. Each element on the periodic table has its own symbol, usually the first letter or two of its name. For example, H stands for hydrogen, O for oxygen, and Fe for iron. The periodic table arranges these elements in a specific order based on their atomic number, which is the number of protons in an atom's nucleus.
The periodic table is not just a random arrangement of elements, it's carefully organized to reveal patterns and trends in their properties. Understanding this organization is key to unlocking the secrets of chemistry.
The periodic table is organized into rows and columns, each with its own significance. The horizontal rows are called periods, and they indicate the number of electron shells an atom of that element has. For example, elements in period 1 have 1 electron shell, while elements in period 2 have 2, and so on.
The vertical columns are called groups, and they group elements with similar chemical properties. This is because elements in the same group have the same number of valence electrons, which are the electrons in the outermost shell that are involved in chemical bonding. The periodic table has 18 groups, numbered from 1 to 18. Some groups have special names like the alkali metals, Group 1, the alkaline earth metals, Group 2, the halogens, Group 17, and the noble gases, Group 18.
Now, let's meet some of the key players on the periodic table. The metals. Metals are a large and diverse group of elements that occupy the left side and center of the periodic table. They share some common characteristics that make them easily recognizable. Metals are typically shiny, good conductors of heat and electricity, and malleable, meaning they can be hammered or shaped without breaking. Think of copper wires conducting electricity, aluminum foil molded into different shapes, or gold hammered into thin sheets to decorate objects. Metals are essential in our everyday lives. From the iron in our blood to the aluminum in our soda cans, metals play vital roles in our bodies, our homes, and our technologies. Section 5. Non-metals, a diverse group with essential roles. On the right side of the periodic table, we find the non-metals, another important group of elements with a wide range of properties. Unlike metals, non-metals are generally poor conductors of heat and electricity, and they tend to be brittle rather than malleable. Non-metals exist in various states at room temperature. Some are gases like oxygen and nitrogen, which make up the air we breathe. Others are solids like carbon, which is found in diamonds and graphite, and some are liquids like bromine, a reddish-brown liquid. Despite their name, non-metals are essential for life. Oxygen is crucial for respiration, nitrogen is a key component of proteins and DNA, and carbon is the backbone of all organic molecules. Section 6. Metalloids, bridging the gap between metals and non-metals. Nestled between the metals and non-metals on the periodic table is a small but intriguing group of elements called metalloids. Metalloids, also known as semi-metals, have properties that are intermediate between those of metals and non-metals. Metalloids are semiconductors, meaning they can conduct electricity under certain conditions, but not others. This unique property makes them essential components of electronic devices, such as computers, smartphones, and solar cells. Silicon, the most well-known metalloid, is the heart of the computer industry. Its semiconducting properties allow it to be used in microchips, transistors, and other electronic components that power our digital world.
Elements are social butterflies. They love to interact with each other. They do this by forming chemical bonds, which are the forces that hold atoms together in molecules. Understanding how elements bond is crucial to understanding how the world works.
There are two main types of chemical bonds, ionic bonds and covalent bonds.
Ionic bonds form when one atom donates an electron to another atom, creating oppositely charged ions that attract each other. Covalent bonds form when atoms share electrons to achieve a more stable electron configuration. The type of bond that forms between two atoms depends on their electronegativity, which is a measure of an atom's ability to attract electrons towards itself. Atoms with large differences in electronegativity tend to form ionic bonds, while atoms with similar electronegativities tend to form covalent bonds. Section 8. Ionic bonds, the give and take of electrons. Ionic bonds are like a game of give and take between atoms. Atoms with low electronegativity, typically metals, are eager to donate their valence electrons to achieve a stable electron configuration. Atoms with high electronegativity, typically nonmetals, are happy to accept those electrons to fill their valence shells. When an atom donates an electron, it becomes a positively charged ion called a cation. When an atom accepts an electron, it becomes a negatively charged ion called an anion. These oppositely charged ions are then attracted to each other, forming an ionic bond. A classic example of an ionic bond is the formation of table salt, or sodium chloride, NaCl. Sodium, Na, a metal, readily donates its valence electron to chlorine, Cl, a nonmetal. This creates a sodium cation, Na+, and a chloride anion, Cl, which are held together by an ionic bond.
Wow, that's so interesting. So it's like a mutual agreement between atoms.
Exactly. It's all about achieving stability. Section 9. Covalent bonds. Sharing is caring in the molecular world. Covalent bonds are all about sharing. When atoms with similar electronegativities interact, they are more likely to share electrons than to donate or accept them. This sharing of electrons creates a covalent bond, holding the atoms together in a molecule. Covalent bonds are like a handshake between atoms. Each atom contributes one or more electrons to the shared pair, and both atoms benefit from having a full valence shell. The shared electrons are attracted to the nuclei of both atoms, holding the molecule together. Water, H2O, is a prime example of a molecule held together by covalent bonds. Oxygen, O, needs two more electrons to fill its valence shell, while each hydrogen, the H atom, needs one more. They achieve this by sharing electrons, forming two covalent bonds between the oxygen atom and the two hydrogen atoms.
So they're like partners working together?
Exactly. It's a perfect example of cooperation at the atomic level. Section 10. The periodic table. A chemist's best friend. The periodic table is an indispensable tool for chemists and scientists worldwide. It allows us to predict the properties of elements and compounds, understand chemical reactions, and even discover new elements. By studying the trends and patterns within the periodic table, we can unlock the secrets of matter and its interactions. From developing new materials to designing life-saving drugs, the periodic table plays a vital role in countless scientific advancements. It's a testament to the power of human curiosity and our quest to understand the world around us. So, the next time you encounter the periodic table, remember that it's not just a chart on a classroom wall. It's a window into the fundamental building blocks of the universe.
Section 11. Stay curious and keep exploring the world of science. That's science in 10 minutes. We've explored the fascinating world of the periodic table and the elements that make up everything around us. We've learned about their properties, how they bond, and why they're so important. If you enjoyed this journey into the heart of chemistry, be sure to subscribe to our channel for more exciting scientific adventures. And remember, stay curious, keep exploring, and never stop asking questions about the world around you.